Today I am here with lecture 4, right? Lecture 4 chapter 2, right? So yesterday I discussed potential energy of 2-point charge, right? So what was the formula? Suppose 2-point charge is separated by r distance, right? Suppose this one is q and another is q, and these 2-point charge is separated by r, right? So potential energy of these 2-point charge is how much? Kq by r. I hope you remember this formula, right? So this is formula to calculate potential energy of 2-point charge. Okay. Now one more thing. Suppose I am going to calculate potential, right? Potential due to this charge at this point. How much will be the value of potential at this point? Suppose this is your point P, right? So potential now potential at P, right? At P due to Q. Suppose that potential is V, and that V is how much? Distance is known to you. Are able to calculate potential. What is the formula of potential? KQ by R, right? This is formula to calculate potential at any point, right? Due to any charge, right? If separation is known, then you are able to calculate potential, right? Now you can see here this term is your V, yes or no? This term is your V. Suppose this is your equation 1 and this is your equation 2. So we can write from equation 1 and 2. From equation 1 and 2, see, this quantity is your V. We can write finally U is equal to V into Q, right? So you can see here, suppose potential of a point is known, right? Suppose potential of a point is known, right? Then you are able to calculate potential energy of any charge at that point. That potential energy will be potential into that charge, right? So this is formula to calculate potential energy of a charge at a given point, right? At a given point, if potential of that point is given, okay? So this way you are able to calculate potential, right? Okay. So just write it down. So suppose the potential at any point, right? Potential at any point is V, right? Potential at any point is V. Suppose here potential is V, right? Then how much is the potential energy of a charge if I bring a charge here? This much, right? This is the potential energy of charge, right? And this potential energy of charge is equal to work done by external, right? Potential energy is definition of potential energy is work done by external, right? So this amount of potential energy of that charge at that point, right? So work done is how much? This much, right? So further we can write, suppose at any point here potential is V, right? And we are bringing a charge Q at this point, right? So potential energy of that charge will be how much? V into Q, right? And this potential energy is nothing but work done by external, yes or no, right? This potential energy is work done by external, right? So you have to keep one thing in mind. Suppose question might be coming different way, right? But you have to remember work done by external is equal to potential energy, right? And that potential energy equal to potential at that point, right? Potential at that point and amount of charge bring at that point, right? This will be the potential energy of this charge, okay? This will be the potential energy of this charge, right? Okay. So next we are going to define potential energy of a charge, right? And then I will define potential energy of a system, right? Those things are somehow different, right? So you have to understand separately, right? What is the potential energy of a charge and what is the potential energy of a system of charge, right? So first I am going to define potential energy of a charge, right? Potential energy of a charge, okay? So now I am going to write this part. Potential energy of a charge, okay? So what is potential energy of a charge, okay? So amount amount of work done, amount of work done, amount of work done, amount of work done needed, amount of work done needed to bring, amount of work done needed to bring a charge, bring a charge q at a point in electric field, at a point in electric field is known as potential energy, known as potential energy of the charge, potential energy of the charge at that point, potential energy of charge at that point, okay. And this potential energy will be how much? This potential energy will be how much? Same formula, this potential. So we can write here potential energy of that charge, potential energy of that charge, potential energy of that charge at that point, at that point is E, at that point is U, right? And this U is equal to V into Q. Same formula, right? The formula you written, right? Where V is where V, what is V? Where V, what is V? The potential of that point, right? V is potential of that point, right? V potential of that point, okay. And what about the charge? Q, what about Q? Q is the charge bring on that point, right? Okay. So this way you are able to calculate potential energy of a charge at a given point, right? So to find potential energy of a charge at a given point, what is required? Potential of that point, right? If potential is known, then multiplying with charge you are able to calculate potential energy, right? Potential and potential energy is different things, right? So you have to keep this thing in mind, okay. So next I'm going to discuss potential energy of system, right? Potential energy of system, okay. Potential energy of system, right? Potential energy of system of charge, right? System of charge means many charges present, right? And we are going to calculate potential energy of that system, okay. So potential energy of system, so potential energy of system of charge, right? Potential energy of system of charge, potential energy of system of charge, right? So what is potential energy of system of charge, right? So same definition, amount of work needed to assemble the system of charge is known as potential energy of system of charge, okay. So first I have to write the definition and then I will try to explain about this one, okay. So the total work done, the total work done in assembling, the total work done in assembling the charge, the total work done in assembling the charge at a given location, right? At a given location is known as potential energy, known as potential energy of the system, okay. So now I'm going to calculate potential energy of a system, right? Okay. So potential energy of system, now we are going to calculate. Now see this figure, okay. So 3 points is given, right? At 3 points 3 charges present, right? Suppose this is your point 1, right? Okay, this is your point 1, right? And position vector of point 1 is r1 vector, right? And here how much charge is present? Here charge q1 is present, right? Okay, suppose another point is here, right? Another, this is your point 2 and position vector of this point 2 is r2, okay. And one more point is present and here charge is how much? Here charge q2 is present, right? and another point is here. At this point, charge Q3 is present, right? And position vector of this point is how much? R3. Right? Now, see how much is the distance of this one? This is the distance between point 1 and point 3, right? That is represented by R13. Distance, right? Not vector, okay? Similarly, we can write here also this one 1 and 2, right? So R1, 2, that means R12 means what? Distance between point 1 and 2, right? And R3, 2, right? So here R23, that means distance between 2 and 3, right? And this is known to you, right? This is your R3 vector, okay? Now, these are the system of charge, right? Okay, these are the system of charge. These are the system of charge. Okay, and we have to find what we have to find? Potential energy of system of charge, right? So to find the potential energy, what we have to find? To find the potential energy, we have to find work done. How much is the work done needed, right? So first I am going to calculate how much work done is needed to bring charge 1, right? How much work done is needed to bring charge 2, and how much work done is needed to bring charge 3, right? If we are able to calculate work done needed to bring all those charges, right, then by adding all these work done we are able to calculate total work done, right? And total work done is potential energy of the system, right? Already I wrote the definition on the blackboard, you are able to see, right? The total work done is the total work done in assembling the charge at a given location is known as potential energy of a system. So we have to find potential energy, right? If we are able to calculate potential energy, right? If we are going to calculate potential energy, then we have to find total work done, right? Total work done we have to calculate, right? So now first I am going to calculate work done in bringing charge 1. Work done in bringing charge 1, right? Work done in bringing charge 1. So now I am writing here work done in bringing charge Q1, right? At R2 is W1, and this W1 is equal to 0. Why 0? Why work done is 0 in bringing this charge, right? Now you can see here, first I am bringing charge 1 by 1, right? So first I bring charge 1, and then I will bring charge 2, then I will bring charge 3, right? So first I am going to bring charge 1, right? So first I am going to bring charge 1, right? That means your charge 2 and charge 3 is not present, right? That means charge 2 and 3 is not present. That means potential at this point is 0. Why 0? Because there is no potential at this point. Potential is mainly due to charge. No charge, there will be no potential, right? No potential means no work done, right? So we can say here this charge is absent, right? So here potential is 0, right? So work done will be 0, right? Now, so one thing is clear, work done in bringing charge Q1 is 0, right? And so I wrote like that, okay? Yes or no? Or you can write like this. You can write in bracket, you can write because there is no electric field. There is no electric field. No electric field means no potential, right? And so no potential means work done will be 0, right? Now next, work done in bringing charge Q2 at R2 is W2, right? And how much is the value of W2? This W2 will be equal to potential at this point, right, into Q2. Yes or no? So we can write here potential at 2, right? So we can write here Q2 into potential at point 2. Yes or no? Right? So how much is the value of potential, right? First I bring charge 1 and then I bring charge 2. So this one is not present, right? Only charge 1 is present, right? So potential at this point will be only due to Q1, right? And that potential is how much? That potential is how much? You know that potential K Q1, right? Divided by R. R is, this one is your R, and this is given how much? R12, right? So R12, okay. So this amount of work is needed to bring charge 2, right? Similarly, we are able to calculate work done needed to bring charge 3, right? Then we have to do same thing, right? Okay. So now you have written this part now. So now I'm going to rub this one, okay? Okay, now work done in bringing charge Q3, right? Work done in bringing charge Q3, right? Q3 at how much? R3. R3 is position vector of that point, right? Is how much? Is W3, right? And this W3 is again Q3 into potential at point 3, right? Q3 into potential at point 3, right? And potential at point 3 is how much? Potential at point 3 is how much? See, this charge will also create potential at this point. This charge will also create potential at this point, right? So total potential energy at point 3 is due to Q1 and due to Q2, right? And that value is KQ1 by R12, right? Plus KQ2 by, sorry, we have to write here 1 3, right? And here 2 3, right? Because you can see now this distance is how much? R13, and this distance is how much? R23, right? Now, so see, now you calculated total work done needed to bring all individual charge, right? So now we are going to calculate work done needed to bring total charge, right? That means total work done, okay? So now I'm going to rub this part, okay? Or wait till I have to remove. Let's remove this diagram, okay? Yeah, it is required. So wait a now. So total work done, right? Total work done to bring system of charge. Total work done to bring system of charge W, and this W is summation of work done in bringing charge 1 plus summation of work done in bringing charge 2, work done in bringing charge 3, right? Now this value is how much? 0. This value is how much? 0, okay? Plus work done in bringing charge 2, okay? So how much was that value? Q2 into KQ1 by R12, right? And now work done in bringing charge 3, this amount, right? Okay, so now I am writing here. So we can write, suppose you are going to bring this one inside, right? So it will come like this. Okay, let me write like that only. K Q1 by R13 plus K Q2 by R23, okay? Yes or no, right? So further we can write K Q1 Q2 R12 plus K Q1 Q3 R13, and similarly we can write K Q2 Q3 R23, right? So this is your total work done, right? And this total work done is your potential energy of system, right? So W you calculated, right? So we can write according to definition, total work done is equal to potential energy of system, right? So you have written this one, right? Potential energy of system, right? So we can write according to definition, potential energy, right? Potential energy of system is equal to work done. It's equal to work done in bringing all charges charges, right? And that is how much? This much, right? Okay. So finally we can write potential energy is equal to K Q1 Q2 by R12, K Q1 Q3 by R13, right? And similarly you can write here K Q2 Q3, right, divided by R23. So this is your formula to calculate potential energy of system. Potential energy of system, right? So with the help of this formula you are able to calculate potential energy of system, right? Okay, so you can see here potential energy is not depend on how I bring this charge, right? Okay, so here I calculating work done in bringing charge from where we are bringing charge, from infinity to that point we are bringing the charge, right? Now you can see here potential energy is only depend on the distance between these two, right? So how many charges here? 3 charges, right? How many pair is possible? 3 pair. 1 pair, 2 pair, 3 pair, right? And each pair will contribute in potential energy, right? So this way you are able to calculate potential energy, right? So take each pair separately. First you take 1 and 2, right? 2 and 3 and 3 and 4, right? And how you are going to take? First multiply these two charges and divide with separation between those two charges, right? This way you are able to calculate potential energy of system. Okay. Now I am going to take one example and going to calculate potential energy of a system, right? So now suppose I am going to take one example, right? In that example, 4 charges given. 4 charges given at each corner of a square, right? This is 1, this is 2, this is 3, right? 4 charges given. This is your Q1, this is your Q2, this is your Q3, Q4, right? And side length is given A. Side length is given A. Question: find potential energy of system. Find potential energy of system. Potential energy of system of charge. System of charge. Find potential energy of system of charge, right? Potential energy of system of charge. Okay, so now again I'm going to do same thing, right? So 1 pair, right? 2 pair, 3 pair, 4 pair, 5 pair, 6 pair, right? So 6 pair, that means 6 term will come, right? So now we can write here potential energy of system. Potential energy of system is U, and that U is like this. This one here, I'm going to start from here. This two, this two, this two, this two, right? And then this one and this one, right? Only these are the pair possible, right? So each pair will contribute in potential energy, right? So first, so potential energy due to 1, right? Okay. So KQ1 Q2 by A, right? Similarly we can write KQ2 Q3 by A, KQ1 KQ3 Q4 by A, right? Plus KQ1 Q4 Q1 by A, right? And now this one and this one, right? So K Q1 Q3 by A and K Q1 Q2 and Q4 by A, right? So this way you are able to calculate potential energy of system, right? Okay, so you calculated potential energy of system, right? We have to take here root 2A. Yes, sorry, we have to take here also root 2A, right? Because this distance is how much? Root 2A, huh? Right? Yeah, so that's I made mistake. Okay, so this will be how much? Root 2A. This is also root 2A. Okay, so this way you are able to calculate potential energy of a system, right? Now, so this, with the help of this example, we are able to understand how to calculate potential energy of a system, right? Now again I'm going to take one more example. In that example, I'm going to calculate potential energy of a system, right? Sorry, potential energy of a charge. In this, we are calculated potential energy of a system, right? Now, another example, we are going to calculate potential energy of a charge. Okay, charge. Potential energy of a charge is different, and potential energy of a system is different, right? Okay. Yes. So write all these things. Okay. So I hope you written this one. So now I'm going to rub this part. This is your system of charge is given, right? Another question now I'm going to take. So this system of charge is given, right? This system of charge is given. You have to find what you have to find. You have to find work done. You have to find potential energy of a charge, right? Find potential. Find potential energy. Find potential energy of charge. Potential energy of charge Q at center of potential energy of charge Q at center of square, right? Now I'm going to calculate potential energy of charge, right? Okay, so potential energy of charge, potential energy of charge, right? Suppose U is potential energy of charge, right? And this U will be what? Q into potential at that point, right? Potential at that point means potential at center. Okay. So we have to find potential at this point, right? How much is the potential at? Suppose this is your point P, right? So we can write here potential energy of charge Q is U, right? And this U is equal to Q into Vp, and Vp is potential energy, potential at that point, right? Potential of point P, and right. And now this separation is how much? So see, total length is root 2a, right? So half will be how much? A by root 2, right? So here to here how much? A by root 2, right? So now potential due to Q1 at this point, how much potential due to Q1 at this point is how much? K Q1 by A by root 2, right? You know this formula, potential is, what is the formula? KQ by R. R is how much? A by root 2, right? Similarly, you are able to write potential at P due to 3 is how much? A by root 2. Similarly, potential at P due to 4, how much? Q4 by A by root 2, right? Okay. So this is your potential energy of charge, right? So with these two examples, I hope you are able to understand how we can calculate potential energy of a system and potential energy of a charge, right? Now I am going to do potential energy of a system of charge in electric field, right? Potential energy of system of charge in electric field, right? Suppose here electric field is existing like this, okay? These are the electric field which is existing in a region, okay? So due to electric field there will be potential, right? If electric field, that means there will be potential, okay? So in electric field I am going to bring charge. I am going to bring two charges, right? Okay. So suppose this is your point 1, right? At point 1 I bring charge Q1, right? Okay. And another point is also present here. Suppose that point is somewhere here, right? That point is somewhere here, right? And that point is 2 here. Here I bring charge Q2, and this point 2 point is in electric field. So suppose potential at this point is V1 and potential at this point is V2, right? So we are going to calculate potential energy of this two charge system in electric field, right? So as you see, potential energy of system of charge in electric field. Electric field is present, and we are going to find potential energy, right? So here, so to calculate the potential energy, we have to find how much work done is needed. Yes or no? How much work done is needed? Okay. One more thing you have to write. Suppose this is your, this 2 point is separated by how much distance? Suppose this 2 point is separated by r distance. Okay. Now tell me how much work done is needed to bring charge q1. So now I am writing work done needed to bring charge q1, right? And that one is how much? W1. And that W1 is how much? That W1 is how much? Q1 into potential of point 1, and that is how much? B1, right? Similarly, we can write work done needed to bring charge Q2 is W2, and this W2 is equal to Q2 into potential at this point, right? Initially no charge was present, so potential at this point was V2. Initially, suppose there was no charge, there were no charge, right? So point potential was this much, right? Now what happened? This charge is came, so this charge will also create potential at this point, right? Okay, so total potential at point 2 will be, due to electric field is how much? V2, and as well as this charge will also create, right? So potential we can write V2 plus KQ1 by R, right? So this much, okay? So total work done we can write, after that I am writing here total work done is W1 plus W2, right? And W1 is how much? Q1 B1, and W2 is how much? Q2 V2, and one more term KQ1 Q2 by R, right? Okay, so this is your formula to calculate work done, right? So total work done, right? And okay, so work done is known, right? And this work done is equal to your potential energy, right? Yes or no? This, so work done is equal to potential energy. Now is U, work done is equal to potential energy, right? So potential energy is equal to this much. So I hope everything is clear to you, right?
Sir, well, how KQ1, how did KQ2 factor?
We have to multiply this one here, right? Now, so next I am going to discuss potential energy of a dipole, right? Potential energy of a dipole in a uniform electric field, right? In a uniform electric field, right? So potential energy of dipole in uniform electric field, okay? Suppose this is your uniform electric field, these are the uniform electric field, okay? And one dipole is kept in uniform electric field, right? Suppose this is your dipole, right? This dipole is kept in this uniform electric field, right? And dipole moment is given, right? Dipole moment is given, okay? Suppose P is the dipole moment of dipole, right? P is the dipole moment of dipole, and here how much charge is present here? Plus Q charge is present here, minus Q charge is present, right? Okay, so this is your, somehow you are able to understand dipole, right? Now in previous chapter I calculated how much is the torque acting on dipole in electric field, right? So I hope you are able to remember that formula, right? So first I have to write, let us consider a dipole having charge plus Q and minus Q, right? Kept in uniform electric field E, right? Okay, so now let us first you write this statement and then make that, then try to draw diagram, right? Let us consider a dipole. Let us consider a dipole having charge plus q and minus q placed in uniform electric field E. Uniform electric field E, right? So first you write this one, okay? Then draw diagram, okay? And then torque experienced. Then we have to write torque experienced by dipole, right? This one first you have to write, then you have to draw diagram, and then now I am going to write that things you have to write, okay? So torque experienced by dipole. Torque experienced by dipole, right? And this torque is how much? P cross E, right? And suppose if I am going to write in magnitude form, right? So we can write P sin theta, yes or no? Where theta is angle between electric field as well as dipole, right? Now this is straight, okay? Somehow it's not look like straight, but this is straight, okay? So you try to draw it like straight, okay? Now suppose someone is rotating dipole, right? Suppose someone is rotating this dipole, right? This torque is acting in which direction? Clockwise direction, right? This torque is in clockwise, okay? Clockwise direction, right? This torque is trying to rotate dipole in downward direction, right? Now, suppose some external agent, right? Some external is applying torque, right? And due to that torque is trying to rotate dipole in opposite direction, that means anti-clockwise direction, right? So due to that he is doing some work, right? Okay, yes. So now we are going to calculate work done by external, right? And he is rotating dipole very slowly, right? So there is no change in angular speed of the dipole, right? So angular speed is 0, very slowly, right? So we can write work done by external, right? So work done, amount of work done by external, right? So next I have to write. So have you written this part? Okay. So now I'm going to draw this part, okay?
So see that work done, external work done, is by the torque or by the external force?
External force will create torque, and that is the external torque. Torque is balanced by torque, right? So once you try to understand once again. So this torque is acting in clockwise direction, right? So we are also so an external agent applying torque in opposite direction, right? In anti-clockwise direction, right? Okay. And as he is applying torque, so he is doing some work, right? So basically we are going to calculate how much work he is doing, right? And
who is doing the work? The torque or the external force?
External. How much external is doing work, right? If we are able to calculate work done by external, right? Then we are able to calculate potential energy. Work done by external is equal to potential energy, right? So basically we are going to calculate work done by external, okay? So I hope everything is clear to you. So now I am going to rub this part, okay? Now we can write work done by external. Work done by external in rotating dipole from angle theta 0 to theta, right? Theta 0 to theta, right? Okay, so rotating like this, okay? Just write like this. So we can write work done by external, right? Work done by external in rotating dipole from angle theta 0 to theta is W external, right? And that W external is how much? Torque due to external into d theta. You know this formula, I already discussed this formula in class 11, right? So work done by external is equal to this much, right? So this torque, we are applying external torque just equal to this torque, right? We are just applying external torque is equal to torque due to this one, right? So just we can replace, we are only applying external torque. How much applying? Just equal to this much, right? Okay, so we can write here an angle is varying from theta 0 to theta, right? Theta 0 to theta, and torque external is equal to this torque, okay, and that is PE sin theta and d theta, right? So now I'm going to integrate it, okay. P is constant, so that will come out, and integration of sin theta is cos theta, okay, cos theta, and this is varying from theta 0 to theta, right? So final formula is coming PE cos theta, PE cos theta 0 minus cos theta, right? Now you calculated the work done needed from this to this, right? Okay, but when I was discuss potential energy due to point charge, right? Due to 2-point charge, right? That time I assumed I have bring charge from infinity to that point, right? Similarly, we are here also we are going to assume we are going to rotate this one. Theta 0 is equal to pi by 2 to theta, right? Okay, so this value will becomes pi by 2, right? If this value is pi by 2, so this value becomes, okay. So here directly we can write it. Here we are going to define, here we are going to define potential energy of dipole, right? Potential energy of dipole. So theta 0 is equal to pi by 2. Theta 0 is equal to pi by 2, right? So we can write finally potential energy at angle theta. Potential energy at angle theta is equal to potential energy at angle theta, right? Potential energy at angle theta is how much? W external, right? And W external is how much? This much, right? And theta 0 is how much? Pi by 2, right? So pi by 2, this value is cos pi by 2 is 0, right? Cos pi by 2 is 0, so this value becomes 0, right? 1 I am writing here also, okay, and then in next step I will do something. Cos theta 0 minus cos theta, right? So finally we can write u theta is equal to, see this value is becomes 0, right? So finally we have minus p cos theta, right? And this further can be written like this: p dot e. So potential energy at angle theta is given by this formula, right? So potential energy at angle theta. Potential energy at angle theta is equal to this formula you have to remember, right? P dot E, right? Okay. So this is all our work for today. Okay. Integration of sine minus cos theta, right? So minus cos theta, so you are going to get this value, right? So finally I got final result same, right? But I made mistake here, right? Here 1 minus sign will come only, right?